Hello all, this is Tom from Tutor Bros. Today we are going to learn how to rewrite the equation of a circle in standard form and then identify the center and the radius of the circle. You'll remember that the standard form of the equation of a circle is x minus h squared plus y minus k squared equals r squared, where the center of the circle is h comma k and the radius is r. So when we are given the general form of the equation of a circle, as we're given over here, to rewrite it in standard form, all you need to do is group the terms with the same variables, then you complete the square, and then you condense the perfect square trinomials into the squares of binomials. So let's do a couple problems together to see how that's done. We'll start with number 1, and I'll rewrite it down here. So we have x squared plus 2x plus y squared plus 4y minus 4 equals 0. Okay, now the first thing that I like to do, it's not absolutely necessary that you do this first, but I usually just like to move the constant term to the right-hand side of the equation to make things a little bit easier. So we're just going to add 4 to both sides of this equation. So we'll have x squared plus 2x plus y squared plus 4y, and then again just adding 4 on both sides, so that equals 0. Okay, then we want to group all of the terms with the same variable, so we're going to group all the terms that have x's in them. So that's going to be x squared plus 2x, and then plus, and then we'll group all the terms with the y in them, y squared plus 4y equals 4. So all we did there was just group all of the terms with the same variables in parentheses. That's it. Okay, now what we want to do is we want to take each of those pairs of terms and complete the square. We do have a video on this if you need to go back to that, but just as a quick reminder, to complete the square, we take the linear term in each of these expressions. So in this case, that would be 2x for the x's and then 4y for the y's. And then we take the coefficient of the linear term, divide by 2, and then square it. And that will give us the constant term that completes the square for each of these pairs of terms. So for instance, in the first set of terms, we have x squared plus 2x. So we take the coefficient of the linear term 2, divide by 2, that gives us 1, and then we square 1, and then we still have 1. So to have a perfect square trinomial, we would do x squared plus 2x plus 1. And then we're going to do the same thing for the y's. So we take the coefficient of the linear term, so that's 4 and 4y, divide by 2 to get 2, and then square it, and that takes us back up to 4. So to have a perfect square trinomial in the second set of terms, we would have y squared plus 4y plus 4. Okay. Now this is important. Remember that if we are adding something to one side of the equation, we also have to do the same thing to the other side of the equation. So we've added a 1 and a 4 to the left-hand side of the equation, so a total of 5. So we also have to add it to the right-hand side of the equation. Now we already have 4 on the right-hand side, so if we add 5 to that, then we would get 9. So don't forget that step. That's very important, and people do miss that sometimes. Okay, now what we want to do is we just want to take these perfect square trinomials and condense them into the square of a binomial. And then again, to do that, we just take the first part of the completing the square process, and then we just stop there. So if we have x squared plus 2x plus 1, we just do the first part where we take the square, or excuse me, the coefficient of the linear term. In this case, that would be 2 for the 2x, and then just divide by 2 to get 1. So then when we rewrite the binomial, it would just be x plus 1 and then squared. So we haven't changed anything. All we did was we took the perfect square trinomial and condensed it into the square of a binomial. That's all we did there. Okay, then we'll do the same thing with the perfect square trinomial for the y's. So that's going to be plus, and then we look at the coefficient of the linear term 4 in 4y, divide it by 2, and that gives us 2. So then we rewrite the perfect square trinomial like this: y plus 2 squared, and that's it. Okay, and then nothing else has changed. The right side of the equation stays the same. That's still 9. And there you have it. Now we have the standard form of the equation of this circle. So it would be x plus 1 squared plus y plus 2 squared equals 9. Right? And then the second part of our solution would be to find the center and the radius of this circle. So remember, go back here if you need to see the standard form of the equation of a circle. So it's x minus h squared plus y minus k squared equals r squared, where h and k is the center and r is the radius. So to find the center, h comma k, we would look at the second term in each of these binomials. So it'd be this one here and this one here. And since in the standard form of the equation of the circle, it's x minus h and y minus k, it's always going to be the opposite sign of whatever the second term is in the standard form of the equation. So since we have x plus 1 and y plus 2, the center of this circle, I'll write it over here, just say the center, is going to be -1 comma -2. Right, so it's always going to be the opposite sign. And then to find the radius, we look at this term on the right-hand side of the equation, and remember that that corresponds to, over here, it's r squared. So to find r, we would take the square root of whatever that number is. So in this case, we would just take the square root of 9, which would be 3. So r, or the radius of this circle, is equal to 3. And there you have it. So this would be the standard form, the equation of the circle, and then this over here would be the center and the radius. That's it. Alrighty, let's try number 2. So we'll erase all this here. I am having a great time. Okay. Alright, now let's copy number 2 here. So we have x squared plus y squared minus 10x plus 6y plus 18 equals 0. Now this one's a little bit different because not all the x terms and y terms are right next to each other, or I should say not all the terms with x's and all the terms with y's are right next to each other. But we can always manipulate our equation, move our terms around a little bit as needed, and then we just repeat the process that we did before. So let's rewrite it so that all the terms with the x's are together and then all the terms with the y's are together. And while we're at it, we'll move the constant term to the right-hand side of the equation. So we have x squared minus 10x, right? And then we have plus y squared plus 6y, and then we'll subtract the 18 on both sides, so that equals negative 18. Okay, so all we did was just move our terms around a little bit, just to make it a little bit easier to condense this into the standard form. Alrighty, then we'll group all the terms with the x's and all the terms with the y's. So we have x squared minus 10x plus y squared plus 6y equals negative 18. Okay. Then we take each pair of terms in the parentheses and we're going to complete the square. So we'll do that with the x's first. So that's x squared minus 10x. And then to find the constant term, remember, take the coefficient of the linear term. In this case, that would be 10 or negative 10. Divide by 2 to get 5. Square it to get 25. So that's plus 25. Okay. Then we do the same thing with the y's. We're going to complete the square. So it's y squared plus 6y. And then the constant will be the coefficient of the linear term, that's 6, divide by 2 to get 3, and then square it to get 9. So we're going to add 9 here. All right. So we've added two numbers to the left-hand side of the equation, so 25 and 9, that's a grand total of 34. So then we're also going to have to add that to the right-hand side of the equation. Now we already have negative 18 on the right-hand side, so negative 18 plus the 34 is going to give us 16. So now our new right-hand side of the equation is equal to 16. Alrighty. Then we take the perfect square trinomials and just condense them into the squares of binomials. So to do that, we would just do, in this case, we take the coefficient of the linear term 10 divided by 2 to get 5. So in this case, it's x minus 5 because the middle term here is minus 10x. So it's x minus 5 squared plus, then we'll do the same thing with the y's. Take the coefficient of linear term 6 divided by 2, so that's 3. So we just rewrite it as y plus 3 squared. And then that's still going to be equal to 16. So there we go. There is our standard form of the equation of this circle, x minus 5 squared plus y plus 3 squared equals 16. All right, now we're going to find the center and the radius. So the center, remember, is h comma k. So we look at the second term in each of the binomials. So that would be here and here. And it's always going to be the opposite sign of whatever is in the binomial in this equation. So the center is going to be 5. It's a positive 5 and a negative 3 because we have x minus 5 and y plus 3. So we just switch the sign. So it's 5 comma negative 3. And then to find the radius, remember we look at this term over here and we just take the square root of it. The square root of 16 is going to be 4. So in this problem, the radius is 4. And that's it.